8.3 is about division and remainder theorem. It means that if we have a polynomial like this and we divide by a linear factor, like maybe x minus 2, if I take this and I divide by x minus 2, if the result is 0, then that means that this thing has a factor and this is its factor. Now, if we divide this by this and we have a remainder, then that means that it is not a factor. So why don't we try that real quick? Why don't I say this polynomial divided by this linear factor? Now, if you remember, we'd had something called synthetic division before, which allowed me to just take the numbers in front, 1, 2, -5, -6, write the long L, and then I set this to 0, so x minus 2 equals 0, so x equals 2, so I put 2 on the outside. Now what I want to do is I want to bring down the 1, now multiply, add down, multiply, add down. So 2 times 1 is 2, add down is 4, 2 times 4 is 8, 3. 2 times 3 is 6, 0. Do I have a remainder? No. So if I don't have a remainder, then this is a factor. Okay? Now, there's another way to check these numbers. So what if I didn't want to do so division is one way. Another way is, what if I just plug in the value 2 to my function? Okay, well, that would be 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6. Okay, well that's 8 plus 8 minus 10 minus 6, 16 minus 16, 0. So whether we plug in the value or we do synthetic division, if we get 0 when we plug it in, or a remainder of 0, then that means the thing that we divided by is a factor. And so let's do another example. And in this example, we'll look at maybe two problems as well. So how about 2x cubed plus 7x squared minus 5. And let's check x plus 3 is a factor, and let's check x minus 1 is a factor. So I want to check both of these. So I'm going to have 2, 7, 0, -5. Now, why did I include the 0? Because we have a cube, a square, but we don't have a linear piece, so I have to have a placeholder. So I'm just going to rewrite that again over here. 2, 7, 0, 5. And I forgot the negative. Okay, now for the first one, if I set x plus 3 equal to 0, I get -3. So let's bring down the 2. 2 times 3, -6, 1, -3, -3, 9, 4. Is x plus 3 a factor of this? No, not a factor. Okay, what about x minus 1? So I set that to 0, I get 1. Okay, so bring down the 2. 2 times 1 is 2. 9, 9, 9, 9, 4. Huh, okay. Well, is this a factor? Nope, not a factor. Okay? So, as you can see, in section 8.3, all we're doing is testing these values with synthetic division or by plugging them in. So, let me plug in the values to show you that it's going to give you 4 and 4. And then and then we'll go from there. So, 2, we said that would be negative 3. 2 times negative 3 cubed plus 7 times negative 3 squared minus 5. Okay, well, negative 3 cubed is going to be negative 27. 3 squared is 9, so 7 times 9 is 63. Okay, so negative 27 times 2 is negative 54 minus 5 plus 63. Okay, this would be negative 59 plus 63 is 4. Okay, so what about if I plug in 1? So 2 times 1 cubed plus 7 times 1 squared minus 5. This is really just 1 and 1, so that's 2 plus 7 is 9 minus 5 is 4. Okay? So in this section, all we're doing is either plugging in the values or synthetic division to see if we get 0. If we don't get 0 for the remainder in the synthetic division, then it is not a factor. If I plug them in and I get a number other than 0, it is not a factor.